Welcome back, geometry folks. We're going to continue our unit going on inside triangles. Today we're going to talk about inequalities within only one triangle. As we know, there's a lot of stuff that goes on within a triangle, but we're going to talk about that in our unit. So what are we going to learn about in this lesson? A few things, quite honestly. Take a look. We're going to talk about the exterior angle theorem again, so we're going to do a little remix, wickety-whack. We're going to talk about angles and sides, and we're going to talk about the triangle inequality theorem. Okay, so we're going to learn about that stuff, and so what else do we have to know? We're going to talk about understanding exterior angles, understanding angles and sides, using the triangle inequality theorem, and then finding possible side lengths. We'll do some neat stuff. But anyway, let's get started with notes. Yay! All right. So the first note is really about logic. Most of this class most of the content in geometry regards thinking and logic. And the first note about the comparison property of inequality is a logical operation. So check this out. If A equals B plus C and C is greater than 0, then A must be greater than B. Wait, what does that even mean? It's addition logic. So let's discuss this. Addition logic. The sum is larger than either addend. Okay, if both the addends are positive. So if we're adding two things, and those two things that we're adding are positive, then the sum is going to be bigger than either of the addend, right? So it's logic, right? It's almost like you're going to say, well, duh. Yeah, but that's going to make a difference later. So hang on tight, pay attention, and buckle up. So that's the first thing. That's the comparison property of equality. Basically, it's addition logic. The sum is larger than either addend if the addends are positive. Okay, so make sure you know that. The next one is the corollary to the triangle exterior angle theorem. Wait, what? Do you remember the triangle exterior angle theorem? You remember where the exterior angles are the sum of the remote interior angles? So you remember this from before? The exterior angle out here, angle 1, is the sum of the two remote interior angles. Okay, so that's the remember one. Well, we're going to use addition logic with that. If that was the case, recall, then clearly the exterior angle, right? The exterior angle is going to have to be bigger than either of the remote interior angles. Okay, so that's what it's going to mean. And what I'm going to do is start to throw a whole bunch of mathy stuff at you, and you're going to see if you can hang on tight. Okay, so we're going to start with logic, and that's the logical piece. Okay, so this is the corollary to the triangle exterior angle theorem. That means the exterior angle is going to have to be larger than either of the two remote interior angles, right? Right, okay. More notes. So some more thinking. Theorem 510 and Theorem 511, you can read this stuff in the textbook. You can pause now and read some more stuff. But basically what these are saying is that the largest angle of a triangle is opposite the largest side of the triangle. Okay, so the largest angle is opposite the largest side. Okay, and quite honestly, the backward is true as well. Okay, so the largest side is opposite the largest angle, and so on and so forth. And so we're going to apply that to ranking all three sides and angles. So we'll talk about ranking sides from largest to smallest, or angles from smallest to largest. Remember how this works. And we're going to discover some more stuff about that in a second. The last note has to do with some hands-on-y stuff. Some interesting things are going to occur. So let's take a look at something, shall we? Let's start with a blank slate here. I'm going to put a few things down, and I'm going to ask, okay, so we have four things here, right? Can we make triangles with all four things? So let's find out. If I look at just the first three things, can I make triangles with that? Well, yeah, right? Take a look. There, I just made a triangle. See how that works? Isn't that neat? Yeah, that's neat. So what's the deal with the lengths of these things? Let's talk about that in a second. Remember, we started with four things. Can I make a triangle with these three things, right? So here's the question. Can I make a triangle with these three things? And of course you're thinking, well, yeah, we can, because it's three sides. Oh, really? Can we now? Let's see. I'll put the vertex there, and I'll move the thing. dude, I can't make a triangle with that, like that. What is going on? I can't do it. So I can't just take 3 random lengths and make triangles. There has to be some kind of fit. Now watch this. This is the deal. How can I tell that this won't work for a triangle? If I look at the sides, right? So I have these 2 sides here. If I add them together, I'm still not as big as the 3rd side. I can't make a triangle. Isn't that weird? So how's that going to work? The way this works is that the only way I can tell if I'm going to be able to make a triangle is if, when I add the 2 sides, remember the triangle we could make? If I add the 2 sides together, will it be bigger than the 3rd side, right? Then, yeah, I can totally do that. Right now I can make my triangle. Okay, so it has to be, at least it's somewhat bigger, not too big, because then we have the same problem as we had before. So it can't be all that much bigger, right? But now, what's going to happen, here's another way of looking at it. If I have these 2 sides, can I tell that what the 3rd side would have to be? Yeah, if I subtract this distance, that the 3rd side has to be that big. And clearly this 3rd side ain't going to work, so I can't make a triangle. So when we're dealing with triangles, you want to consider this type of example, what's going to happen. And then what we're going to do is throw a whole lot of numbers and symbols at you by adding and subtracting. So let's see what just happened, how that would look with numbers. This is the note now, right? So the triangle inequality theorem is what we just talked about. The sum of the lengths of any 2 sides is greater than the length of the 3rd side. Okay, deal. But let's talk about this. If you have 2 lengths of a triangle, that 3rd length must be between the difference and the sum of the 2. Because if it's between the difference and the sum of the 2, then we're going to have a triangle. If it's less than the difference, well, we can't make it. And if it's greater than the sum, it's now too big. And we'll do some more examples later. But that's the triangle inequality theorem. So remember this example. Can't make a triangle here. We can make a triangle there. Okay, so that's that. Let's do some examples. All right. Now we're going to start understanding exterior angles. So let's go talk about that note that we made with exterior angles. So do you remember that note? Exterior angles, right? Using that addition logic. The exterior angle is larger than either of the 2 remote interior angles. So here's this first question. Take a look at this diagram. The question is, why is the measure of angle 2 greater than the measure of angle 3? Well, let's take a look. What is happening with the with these angles 2 and 3? Is there anything going on? Well, we have here an isosceles triangle, correct? Correct. That means angle 2 and angle 1 are congruent, correct? Correct. Now, let's take a look at angle 1. Do you see angle 1? What do we call angle 1 if we were paying attention to only triangle ABD? What would we call angle 1 if we look at triangle ABD? Angle 1 is the remote exterior angle. An exterior angle. So angle 1 is an exterior angle. The remote interior angles are 3 and 4. So if you recall from the note, right? Remember, exterior angles are the sum of the remote interior angles. So that means angle 1 is the measure of these 2 added together. That means angle 1 is bigger than either one. And if angle 1 is congruent to angle 2, well, angle 2 must be bigger than either angle 3 or angle 4. So clearly, angle 2 has to be bigger than angle 3. So why is the measure of angle 2 bigger than the measure of angle 3? Because of the comparison property of inequality, that the sum is greater than either of the addends. Okay? Similarly, the next question here. Why is the measure of angle 5 greater than angle C? Well, let's take a look at angle 5. You see angle 5? Here it is. What is angle 5? Well, let's look at triangle ACD now. See that triangle, ACD? Huh? See that? Angle 5 is an exterior angle. If that's an exterior angle, what are the remote interior angles? We have 3 and C. And if angle 5 is the sum of angle 3 and angle C, this must be bigger than either one. So measure of angle 5 is greater than the measure of angle C. That's the comparison property of inequality. Logic. Logic. Yay! Okay, so hopefully that helps you think. Anyway, next example. Now, we were going to talk about angles and sides, right? We talked about the second note where we discussed that the largest angle of a triangle is opposite the largest side. Okay? The largest angle of a triangle is opposite the largest side. Remember? Remember. Okay. So then we have this example. Town park is triangular. The landscape architect wants to place a bench at the corner with the largest angle. So that's going to be opposite the largest side. What's the largest side? 175. So what's the largest angle? Here. How do we answer the question, though? Okay, how do we answer the question? Which two streets form the corner? Which two streets form the corner? Well, clearly we're talking about Valley Road and MLK Boulevard. Okay, so at the corner of Valley and MLK, there, done. That is the corner with the largest angle. Okay, so there's that note in action. We're going to ask you questions like that too. Oh, I'm not done with that map, guys. I ain't done. Let's take a look at this next one. Suppose that architect wants to place a drinking fountain at the corner with the second largest angle. Ooh, now I'm throwing in second largest. You better read, so you got to be careful when you're reading. Second largest angle means I'm going to deal with the second largest side. What is the second largest side? We got 175, 120, 105. 120 is our second largest side. And remember the note. The angles are opposite the sides. That means the second largest angle is out here. Okay? So which two streets form the corner with the second largest angle? Well, now we're at the corner of Hollingsworth and MLK. Okay, so now we're at Hollingsworth and MLK. Does that make sense? I hope so. If not, pause, rewind, look at the notes. Okay, so that's the deal. So that's understanding the relationship between angles and sides. All right? Next, let's understand some more angles and sides. Now, this is a good one because it involves a little bit of math. So now we have the question, we're going to name the sides of triangle TUV in order from largest to smallest. Now, it's going to be so critical that you pay attention to the order because order matters. If I say largest to smallest, you darn well better give me the largest to smallest. The only question is, we only have two angles. So what do? We have to find the third angle. Find it. Bloop. How do we find it? Well, we have our two angles, our 58 and 62. And so if we add those together, we now have 120 degrees. So this angle must be 120 taken away from 180, right? And it would leave us with a 60-degree angle. So the angle up here is actually 60 degrees. Now we have all three angles, and now we can start putting things in order. And again, remember the notes. The largest angle is opposite the largest side. The largest side is opposite the largest angle. So let's apply that. If we're going to talk about largest and smallest. What is the largest angle? 62. So this is our first biggest angle. What's the side opposite? Side TU. Okay, so our first part of the answer is going to be segment TU. That's how that should look. Okay. The second largest angle is 60, so the side opposite it is UV. So segment UV is next, and then that leaves 58 as the smallest angle, which means TV is the segment. So we have now ordered this from largest to smallest. It is so important that you pay attention to order because the order matters. Okay? So that's how that one works. Moving on. More examples, cats. You got it. So here's another triangle. The measure of angle S is 24. The measure of angle O is 130. Name the sides of SOX in order from smallest to largest. Okay? So let's put some stuff here. The measure of angle S is 24. The measure of angle O is 130. What must the measure of angle X be? Let's take a look. So we add our 130 and our 24. We have 154. If we take that away from 180, that will give us 26 degrees. Aha. So that's interesting. The measure of angle X is 26 degrees. Keep that in mind. But now also pay attention. We're going to order the sides from smallest to largest now. Order matters, pay attention. Okay, so it's so important that we read carefully and pay attention. Okay, so we're looking for smallest to largest. The smallest angle in the triangle is 24 degrees. So that's how we're going to begin labeling. This is the smallest angle, so this one's going to be first. Okay, our first angle to look at is 24 degrees. What's the side opposite? Side OX. And so we label that segment OX. Second smallest, opposite 26, which is SO. And then the third, which of course is the largest, from SX. And that's how we would construct our answer. We put the segments in order. Okay? So that is understanding angles and sides. Now, let's do some more thinking. We're going to talk about that triangle inequality theorem. Okay, so let's take a step back for a second and remember the note that we discussed when we were looking about the sum and the difference of sides. So remember the note that we had where I think I kept it here. This one. If you have two lengths, the third length must be between the difference and the sum of the two. Okay, so how does that work? Let's see this working. We have three distances. Can a triangle have that? Well, let's take a look. If we look at the first two lengths, 3 feet and 7 feet, if we look at the first two, what's the sum of 3 and 7? Right? 3 plus 7 is equal to 10. Okay, and then what's 7 minus 3? 7 minus 3 is equal to 4. So if we're just looking at the third side, if we ignore the 8 for a second, if we're looking at the third side is going to have to be between 4 and 10 in order to make a triangle. Remember how this worked, because this could not work. Okay, so the third side is not, this third side is bigger than the sum. Okay, and if we're looking at triangles, it can't be bigger than the sum. It also can't be less than the difference. So the third side has to be between 4 and 10. And guess what number is between 4 and 10? 8. So yes, it works. Okay, 8 is between 4 and 10. This can totally work. Now, here's a neat question. Moving on to example B. Let's take a look at the first two. We have a length of 5 feet, 10 feet, and 15 feet. Can this work? Well, let's look at 5 and 10. 5 plus 10 is 15. And 10 minus 5 is 5. That means the third side of the triangle has to be between 5 and 15. Is 15 between 5 and 15? That's the question. The answer is no. 15 is not between 15 and 5, right? Because 15 is 15. It's not less than 15. It's not in the middle. 15 is 15. It's not less than 15. It's not between 5 and 15. Okay, so this is 15 is. So what's going to happen? Let's say we had something similar to this, right? Let's say we had a 5 feet and a 10 feet and a 5 feet thing. What happens if the third side is 15 feet? We can't make a triangle, right? There's no we can't triangulate that. It's not going to work. It's going to be too big, right? So we can't triangulate. So 15 is not 15. So this is not a valid length. Does that make sense? It better. If not, pause, rewind, listen carefully. So 15 is not between 5 and 15, therefore this cannot work. Okay? Okay. Now, can a triangle have sides with lengths 2 meters, 6 meters, and 9 meters? Explain. Well, let's figure it out. Let's look at our 2 and our 6. 2 plus 6 is 8, and 6 minus 2 is 4. So the third side is going to have to be between 8 and 4. Is 9 between 8 and 4? No. So can a triangle have sides with lengths 2, 6, and 9? No. Explain? We just did. It's not between 8 and 4. 9 is bigger than 8. So no, it cannot work. Okay? So if you want the explanation, 9 is bigger than 8. There's some silly commercial that's going on now, like 6 is greater than 1 or something like that. Like, yeah, a lot. Anyway, 9 is bigger than 8. Hopefully that makes sense. Moving on. Finding possible side lengths. This is where things get fun. We have to start thinking now. Take a look at this. In the solve it problem, we explored two possible dimensions of a triangular sand. Basically what we did with the markers. Two of the sides of the sandbox are 5 and 8. What's the range of possibilities for the third side? Okay, so now we look at this. This is very similar to what we just did. So we have 5 plus 8 is 13, and 8 minus 5 is 3. So that means the third side has to be between 3 and 13. Okay? So we can say the range, right? What is the range of possible lengths? It's from 3 to 13. Okay, so from 3 to 13, that's the range. That is actually the answer. Feet, by the way. 3 to 13 feet. That is the answer to this. Okay, so what's the range of the third side? It could be anywhere from 3 feet to 13 feet. But it can't be 3 feet, and it can't be 13 feet. So how do we do this? Okay, so it's between 3 and 13 feet. How do we do this? There's a mathy way of showing range. We could say blank is less than x, which is less than blank. In fact, range is more y, but whatever. So blank is less than x is less than blank. When we say between 3 and 13, or from 3 to 13, when we say that, we can write that in mathy ways. We can say this, that third side, the possible length of the third side is going to be from 3 to 13 feet, right? But the values are in the middle, and they're bigger than 3 but less than 13. Okay, the values are bigger than 3 but less than 13. The values are bigger than 3 but less than 13. How cool is that? Okay, so that's a mathy way of saying range. We will see this, so be prepared. That's what it looks like. It's called a compound inequality of an intersection, but whatever. So, next question. Triangle has side lengths of 4 and 7. What is the range of possibilities of the third side? So here we go again. 4 and 7. 4 plus 7 is 11. 7 minus 4 is 3. So it's between 3 and 11 inches. Okay, between 3 and 11 inches. That's the range of possible lengths of the third side. Now, is there a mathy way of saying this? Absolutely. The values are bigger than 3 but less than 11 inches. Okay, so you can say that in very mathy ways. And you can look smart and impress your friends and family. So that's how we find possible side lengths. Cool? Cool. Quick quiz. All right, so let's look at this top diagram. It says, which is the smallest angle in MNO? So we have this diagram here. We have MNO. And we have lengths. And we're looking for the smallest angle, which is going to be opposite the smallest side, which is 17. So angle M is your smallest angle, right? Piece of cake. You say, all right, it's easy, cats. True. The next one. Good thing I told you about mathy ways of saying the range, because look. Anyway, the sides of the triangle are 5 inches and 10 inches. What's the range of possibilities? So 10 plus 5 is 15. 10 minus 5 is 5. So we're going from 5 to 15. Which one of these is the mathy way of saying between 5 and 15? Down there. Okay, so it's that same thing we talked about. The values are bigger than 5 but less than 15. Okay, so that's how that looks. So anyway, that's our lesson on inequalities in one triangle. Hopefully it was fun. Hopefully you got to think, and I'll see you on the next lesson. Bye.